yes, creepy screen here. Isn't this creepy?
Yeah.
It's like one of those funhouse mirrors. Yes, but welcome. I'll make it less creepy. There. Coming soon? No, coming now. I need to change that. So I'm Lisa. Welcome to Longitudinal Multi-Level Models. I'm new here. I've been here for a month now. I just literally finished unpacking the last box from my office a few minutes ago, so I'm very proud to say that. I've been teaching this course for a number of years. I asked to teach something that I had already taught, given the hassles of moving and whatnot, so hopefully things will go well. I have to say I haven't had as tight of a group as this in quite a while, but that just means that we'll have more time to get to know each other. So everything for the course is going to be on this webpage. I sent you the link, but if you can't if you don't have access to your email, you can just pull up a browser and type in my name because I own the Google. This is one of the nice things about having a name that is spelled differently. If you type in Lisa Hoffman, that's Lisa with an E, you will find my webpage. There are a few other Lisa Hoffmans out there, but none of them have longitudinal modeling web pages as near as I can tell, so you'll be able to find mine. I keep all of my courses on this, that way I can keep them open to the public. So from my website is linked, there's a page for course materials, and here it is. So the format of the course is lecture, but I don't want to be the only one talking. I want all of you to stop me as often as you need to and ask questions. Be the person with your arm in the air every 5 seconds because that is the person who's going to take something from this. I especially like questions that, well, what I think you said is, can I try and say it a different way and see if I'm following? Or I have this study and I'm thinking about how what you said might apply to me. Can I try to talk about that? Those are great kinds of questions. So please, let's make this as interactive as possible. The course office hours are going to be in this room immediately after class. That way I can help multiple people at the same time with homework assignments. You're welcome to come and talk with me about anything. It doesn't have to be this course. If you have other analysis questions or just other random things, if you'd rather meet with me in an individual format, that's fine. Just shoot me an email and we'll find a time to meet. I have no idea which way south is from where I am.
No.
Well, so you two are both contradicting each other. It's not just me. Do you know how I got here? I walked outside and then I'm like, well, I know there's another entrance. I wasn't going to trust myself to get through the building correctly. But yes, I'm in the south side, a couple doors down from the main office, but I plan to be in here for office hours. The textbook for the course is mine, I'm happy to say. I spent 5 years writing a book, and I'm happy to be able to use it in the course. The book was written for people who are trying to teach themselves these models, but don't necessarily have a class in front of them. Because that was how I learned it, quite frankly. That was my experience with these models. As a graduate student, I was a graduate student at the University of Kansas, where I also was just a professor, but that's a separate story. One day, my supervisor for my G area appointment, which was in a data analysis type center, handed me a book, which is the Snyder's and Bosker multi-level modeling book. And she said, someone needs you to learn how to do growth curves. Learn this. And that book is one of the easier multi-level modeling books, but it still took me about an hour a page, I would say, to get through it. And luckily, I had someone to ask questions, and I could take my work to her, and she'd be like, yeah, that's not right at all, and come back and try it again. And when I graduated, I knew just enough to be dangerous. That's someone who can run the software and get numbers out. Maybe they're right. The software doesn't care. It'll give you numbers no matter what you put in your model. So I went to Penn State as a postdoc, and I had the chance to audit a class on these models, and I was the person with my hand in the air every 5 seconds trying to make sure that I could follow, and I started to put it together. My last year as a postdoc, all of the methodologists went on sabbatical at the same time, and they had no classes, and so they're like, you want to try to teach it? Sure. I know these models now. I learned them 5 minutes ago. How bad could this go? And standing up in front of people and having to answer questions, I realized I knew nothing at all. So I spent about 40 hours a week reading books, trying to learn the answers to the questions that came up and trying to get better at this. And so that's been my story, is clawing my way through these things. And so I wrote the book for people to have the introduction that I wished I would have had. Because so much of these models are not hard, but they're complex. Do you know what I mean? Like there's difficulty and then there's complexity. These models are not that different from regression, but there's just a lot of stuff going on at the same time. Coupled with that is new vocabulary. The vocabulary is inconsistent across disciplines. So you have a whole new set of synonyms to learn. Not just that, the notation is inconsistent across disciplines. The software is inconsistent across disciplines. So it takes something that in theory is within your reach if you understand regression, and it makes it harder to tackle if you don't have sort of the orphan Annie decoder ring to capture all of these things. So that's my job, is to make it easier for you to learn this stuff. The approach that I take is very applied. I do have equations, I do have vocabulary, but all of the work that you will do in this course is to try and get a practice, to get a sense of how to do data analyses for real. So there are no exams. There's nothing that's high stakes where you only get one shot and that's it. I don't believe that's effective, and I don't think it's trained you for what you need to do in the real world, which is learn from your mistakes. You know, in academia, you get revise and resubmit for your papers, right? As a best case scenario, if you turn in a grant application, the best case scenario usually is you get a score to work from, and then you revise and resubmit, right? Learning to build off of your mistakes and get better is the skill that I want you to practice. So after we get a sense of who all is going to be in the course, and by that I mean not just students but also auditors, I'll get the roster going for the online homework system, and I'll demo that next week. For now, all you have to do is read along with the lectures. In terms of reading, I actually recommend that you read after the lecture, because I feel like if you have me to just give you sort of the big picture standing in front of you, then the details come in the book, and that gives you something to organize them with. Obviously, reading is something that is important. It may take multiple times through in certain sections. I know chapter 5 nearly killed me to write it. I'm guessing that it's not something you're going to read one time and be like, I got it, let's move on. Whereas other stuff like chapter 1 that's more conceptual maybe just takes one time through. So those are the things that you're supposed to do. The creepy screen here that we started with, this is software that's actually recording this lecture. So although it killed my browser just a moment ago, I was trying to show you my YouTube channel. After class, along with the materials for each lecture, there will be a link to the video from class. Sometimes I screw up, sometimes I forget to hit record, sometimes my microphone dies. I usually have a clip-on microphone, that way I can wander around, so I can't promise there will always be videos, but my intent is that there is. And that helps both me and you. I know you guys have busy lives and other commitments. If you need to be out of here because you have a sick kid, or you have comprehensive exams, or you're at a conference, or whatever, you can follow along with the class. It actually will be live streaming during the time that this is offered. The other reason that I do it is that I've taken a lot of stats classes and I've taken a lot of stats workshops. And if I had $1 for every time I thought to myself, you know, if I could just hear that one more time, I think I would have had it, I wouldn't need to be doing this because I'd be rich. So now you can hear it as many times as you want to. You can go back and listen and re-listen, and if it's still not clear, then you can ask me about it. But that helps to cut down on the number of individual questions that I have to answer when I've already said it, and I can say, oh, I talked about this on this week, go look at this video. And then you can review on your own whenever you need to, in addition to having me as access. So that's my spiel. I want to get to know each of you. Learning your names should not be all that challenging, given the number of people in the course. So if we could do the thing where we both introduce ourselves, say why you're here, or what you hope to get out of us, something that would help me remember who you are besides your name, that would be good. So I'm going to start with you. Are you Michelle?
I'm Michelle.
Yes.
I'm Michelle Voss. I'm in the Department of Psychological and Brain Sciences. I'm a faculty there. Actually, one of my students is also in our audit, James Kent. He's a senior grad student, very quantitatively oriented. And so I took a lot of quantitative classes. I went to the University of Illinois, and but mostly just basic regression, and then your experience of clawing your way through what the more mixed effects models are has been my experience as a new faculty member and having more complex designs that I run in my lab. We do intervention research, and very interested in within-person change as can be affected by physical activity or any other intervention and how it affects memory. And I feel just enough to be dangerous, just good enough to be dangerous, and we work with a statistician, and even just being more fluent in those discussions will be helpful, so that's why. Yeah.
That's great. And thank you for making the time to be here. But
Yeah.
I won't hold it against you if you're not here.
Yeah.
Yeah. I've had great intentions to audit things, and usually it's really hard when something's pressing on you to hold up those intentions. But thank you for joining us. And please be the loud one.
I'll try.
Yeah, somebody's got to be, right? That was me. It can't be me this time. I've got to share the load. So thank you, Michelle.
Sure.
And you are?
Ismail.
Ishmael.
Yes.
Okay.
My name is Ismail. I'm a third-year PhD student at the Education Management and Statistics program here. I had my master's degree in UK about educational assessment. We have been collecting data about personal assessment before me and after me for 5-6 years right now with Dr. Wispo, and Longitudinal analysis will help a lot
Great.
using those data for my PhD dissertation and also in the future for the publications that we are coming.
How many occasions do you have?
Over 1,000.
Oh, per person? Or
Excuse me.
occasions, time
Occasions.
points.
Oh, we have 3 occasions per semester.
3 occasions
Which
per
means,
semester.
One time, 2 weeks later, 2 months later, something like that, to minimize the memorization effect.
Gotcha. Is it a different set of people each semester?
Sometimes the measurement tools are different. We are putting sometimes the Big 5, sometimes VFI and evaluation studies as well. For 2 semesters, they are the same people, but they are coming from the same population, not the same people through all years. So it's very complicated. Like for 3 years, they are the same people. For other 4 years, they are the same people. But for the first 3 years and the other 4 years, are not the same people. Something like that. So it's very hard to keep on. But for the 3 years and 4 years, I believe that.
Okay, well, I think that will make a great example of additional sources of nesting or clustering. Those are synonyms. So I'm gonna call on you about that, just to warn you. Ishmael.
Yes.
Ishmael. Okay. Sir?
My name is Ko Hong Chang, and I'm a doctoral student in educational management and statistics. And I'm also a research assistant at the CASPA. And the reason I want to take this this class is because I'm interested in analysis during longitudinal data. And eventually I want to use the IRT model to model the longitudinal data.
So growth of thetas?
Yeah.
Change in theta, is that the goal? Okay, I can get you the growth part, but someone else is gonna have to get you the theta part. You cool with that? Okay. So that's the other set of courses that I've taught before is measurement courses. Unfortunately, I haven't gotten to put them together yet. But if you know how to get the thetas, I can work with you from there. Okay, and your name again was?
Kofong.
Kohong?
Kofong.
Kofong.
Yeah.
Kofong, okay. Yeah, I'm sorry, I'm terrible with names. I'm great with data and terrible with names. Like 10 years from now, I will tell you all about the research studies that you mentioned in class and have no idea what your name is. That's the story. So Kohong, Ishmael, Michelle, and?
My name is
Mia?
Mia.
Minya?
Ninja, like
Mingja.
Like a ninja.
Yeah.
That's good.
Good.
Mingja like a ninja.
Yeah.
Okay, I can work with that. Great.
So yeah, I'm also a PhD student in the educational management statistics program. I'm now actually working for the ILA assessment and partially working as a TA for a statistics class. So I know the ILA assessment is have multiple administration of tasks during a year for the same students. So I'm very interested in the longitudinal study.
So I'm just making sure none of my students are here.
He must be in 166 South, is my guess. Or something. Yes. So, sorry, you were saying?
I'm interested in applying the longitudinal methodology to the data. So I'm taking this class to enlarge my perspective.
Great, welcome. Minja? Minja? Say your name again, sir, I'm sorry.
Kofong.
Kofong? Okay. Ishmael. Okay, all right.
My name is Harry. It's like Harry Potter, Harry.
Harry, okay.
That's my real name. From South Africa.
Yes, he will call them mixed effects models, by the way. That's the same thing. That's another set of synonyms we have to learn. Yes, okay. Harry, got it.
Hi,
Okay.
my name is Daniela Cardoso. This is starting my 5th year in Education Management Statistics PhD program. So, I'm an ACT scholar, so I'm in fellowship here. And then I'm here because my advisor encouraged me to look into a learning approach because of the data set that we currently are working on with, and it's called the Student Experience in Research Universities. It's administered by research learning universities across more than 10 universities to undergraduate students. And we've recently even started a new students at grad students.
And yes, we talked this morning about all the potential levels of complexity there as well. So yeah. Yeah, the good news is that even though this course is longitudinal, I call it longitudinal multi-level because it's also a backdoor into multi-level or mixed effects models more generally. The same techniques can be used to analyze data, any kind of data in which you have more than one dimension of sampling. That's the generic term. So in her case, if you have multiple occasions from the same person, then you have occasions and people, that's 2 dimensions. If those people come from different places, classrooms, schools, districts, or something, that's another dimension. I'm trying to think, if you have, let's say, if you're looking at different brain regions, right, that could, if you're sampling like in, ERP channels or something, and you're sampling from different regions, that could be another sampling dimension. So you may have different electrodes over different occasions, over different trials for different people. So these models, generally speaking, are well suited to address multiple kinds of sampling and all of the different types of variability that come along with those multiple types of sampling. So it's hard to learn multi-level models without an immediate context to go to that's nailed down, and so that's why it's longitudinal. Even though, for those of you who are interested, I'll try to make extensions into how these same techniques would be used for a different type of design. But we're going to stick with just time and sampling unit, which I usually say person, but it could be multiple things. It sounds like it's going to be person for everybody in this room based on your experiences. We have students, subjects? Older people, participants? Yes. And students, people? Students, okay. So people works for this group. I've had people from biology before that have rats. So occasions within rats I've also had folks from education who are studying properties of schools, and so we have school level outcomes where the school is the person essentially. So it'll be people for us in that case, so good. By the way, your voices will not be picked up very well on here, so you don't have to worry about sounding stupid on the internet. That's my job. I get to stand here and say all of that. So, all right, so now I know you guys, and you know me. Do you have any questions before we dive into stuff? The printable syllabus I have here really it's for your records in case you need to have a syllabus for this class. As we move through the semester, if we get behind, I'll juggle things a little bit. So this will always have the most current thing that we're doing each day. Due dates are also noted on here. You'll see there's 2 different kinds. There's homeworks and there's quizzes. So I'm trying to the best of what I could do in terms of the schedule to have either one or the other due each week, either a homework assignment or a quiz. The idea of the quiz is that it's meant to be a review. So it's big picture stuff. What do I want you to have taken from the recent material? Things that you should be able to answer off the top of your head. If you can't, consult your references and go back and read some more because that gives you a sense of what you might be missing. The quizzes are participation only, meaning if you do it, you get the points. I don't grade them. Instead, what I will do is provide what I think the correct answers are to each question, and when you submit it after the due date, you'll be able to see those, and then we'll go over it in class as a means of review. So I have those sort of every other week in between the assignments. All of the assignments except for the first one, like I said, we'll use the online homework system, which I'll show you next week, so we don't have to worry about any of that. I will note that you get an opportunity to earn extra credit right off the bat by helping me test the system, making sure everyone can enter it. So you get 3 points, and that's 3 out of 100. I don't do like 500 points a semester kind of thing where you have to do the math, it's just 100. I give you 3 points for helping me test the system extra credit. And the reason that I'm so generous is that each subsequent homework, if it's even a minute late, and you'll note that I am very specific about the due dates here, 11:59 p.m., if it's even a minute late, it loses 3 points. I realize that's harsh, but in my experience, things with hard deadlines get done. So it's a hard deadline. That being said, you get a freebie for testing the homework. The other thing is that you'll note at the bottom here and describing the policies, if you're looking at the syllabus and you think, oh, I'm going to be out of town that whole week, I don't know how I'm going to get that homework done, send me an email. Ishmael, right, has already done that because he's taking comps, so I've given him an extension on some of the homeworks. If you are planful, that's the thing, at least 2 weeks in advance, I will let you change the due date to work with your schedule. So planfulness is good, reactiveness is not so good. So late quizzes are off 1 point, and so you get 2 points for submitting it, so it's basically half off. All right, I think that's all I wanted to say about that. Everything is due on, the homeworks right now are all due on Fridays. That's my intent so that you have a weekend. I believe in downtime.
Other things.
Yes, so you can catch up on the rest of your work on Saturday and Sunday, or you can do your laundry, or you can take a nap, right? Or you can play with your children, or whatever it is you want to do. But I'm trying to save you from yourself by not having it due on a Monday, right? The other thing is that since I have office hours on Tuesdays and Thursdays, hopefully Thursday gives you a chance to get your questions answered and still have time to submit it by the end of the day on Friday. So. There's 2 classes where we're getting booted out of here by comprehensive exams. I have those noted on the syllabus, the 7th and the 28th. So we are in a other classroom that is, I don't know which direction, but someone showed it to me and I will get there eventually. Okay, so. All right, anything else before we jump in? We're ready? We're excited? Clearly, I'm a little too excited. I've almost finished my daily allotment of caffeine. Is this a Pepsi campus or Coke? It's Coke? Okay, well, this is contraband then. Cheers.
I didn't know that.
It's what?
I didn't know that universities could only have Pepsi or Coke.
It started when I was an undergrad, and so I was at Nebraska as an undergrad, and it was Pepsi. And then I moved to KU, and that was Coke. And then actually I took my first job at Nebraska and it was still Pepsi. And then KU switched to Pepsi, but there was no Diet Mountain Dew to be had anywhere on the campus. I know, you have a gas station across the street. How awesome is that? That's like the reference point for my downtown. It's like, okay, gas station. All right, there's my parking garage. There's the building. It's like, it's very helpful to have a landmark that is so discrepant from all of these other, like, you know, old nondescript buildings, right? Gas station, got it. All right, so away we go. And yes, I have you in a classroom so that you can work on the laptops if you want to take notes electronically. If you're a paper and pencil kind of person, please print them out yourself. I'd tell you where a printer is, but I don't know. So you'll have to figure that one out on your own. But I've got the slides here for reference. So this is just kind of an overview of what some vocabulary, some concepts, a sales pitch to get you to come back, and then a list of what I hope to cover this semester. So what is this class about? Longitudinal data, just to define the concept. It is the same individual units of analysis, so an entity, like a person, sampled repeatedly. Now, repeatedly can be lots of different things. So in your intervention work, for instance, how long does it take for someone to improve their physical fitness?
3 months.
3 months. Okay, so you might measure them once a month, every couple weeks?
Fortunately, before and after.
Before and after. Okay, we got to work on that.
We're doing, but yeah, that's
Yeah, we'll come back to that. But yes, so 3 months. I am familiar with the Seattle Longitudinal Study. It's an aging person, yes, Warner Shia. His dissertation, I believe, in 1956, it's still going. So they measure people every 7 years, and at this point they've gotten the children and the grandchildren of the original people in the study, and they're able to do all kinds of things. That's a very different time scale from something like someone wearing a heart rate monitor. So there's studies where you might show someone a scary video and see how they react, those sorts of reactivity response things. And that unfolds over seconds. All of these things are equally longitudinal. Different types of models may be more or less useful for those different types of measurement schedules, but they all fall under this umbrella. The other thing that's related to this that I've packed into the last week or two, and hopefully we can get there, is other kinds of repeated measures data. So studies in which the same people respond to the same items, those can be analyzed with these models as well. So you have predictors or covariates that might describe differences between people in those studies. You might also have deliberate differences between stimuli. So like in psycholinguistics, people might have to decide if a given set of letters is a word or not a word. And the speed with which someone can do that will depend on characteristics of the stimulus. So people may be interested in what features of those stimuli predict differences in performance, what features of the person predict differences in performance, and what unique combinations of the two. Those types of studies, even though it's not about time per se, can also be analyzed with these sorts of models. So that's why chapter 12 in the book is other kinds of repeated measures. People measured repeatedly, not over occasions per se, but with different stimuli. And then you have designs like eye tracking types of research, where you might have somebody's continuous eye movements monitored while they're looking at a picture performing a task. Each picture is a stimulus, so that's one dimension of sampling, different people is another, and then watching what happens to their eye movements over time is a third. So those types of designs then would borrow from both of these things simultaneously. Generally speaking, these would be considered multivariate data. That word to me has a very specific definition. It means multiple outcomes from the same person. There are multivariate textbooks that are sort of a catch-all of everything that's not in your first regression class, like logistic regression or other things. That's not multivariate. Multiple variables in the model doesn't make it multivariate. Multiple outcomes does. It's the outcomes that make it complicated because we have to be able to introduce terms in the model that capture why and how the outcomes are related to each other. So that's what we're talking about here, is multivariate data broadly construed. And the idea in this course that we'll see is that we're using something called random effects to help describe covariance, or how the outcomes are related to each other. So what do you need to be able to participate? What kind of data do we have? Well, to start with, the models we're going to talk about are building from just classic linear regression. So we're talking outcomes that are intervally measured, continuous outcomes, plausibly normal. That means a 1 unit difference means the same thing at all the points in the scale. If you're using a subscale of some kind, it means that everything that you've summed together to create a total score contributes equally. You can use thetas to get around that problem, or linked scores if you have different types of instruments. At the end of the day, though, we have to have something to measure growth in. We're going to be using observed variables. These models can be extended to latent variables to do a simultaneous analysis as well. And I have an asterisk here because we can do longitudinal modeling on any kind of outcome, not just normally distributed stuff. Apparently I said something wrong. It's just that those models are harder and they're not a place to start. So I mentioned logistic regression. Do you guys have you had that in courses before? Have you done it? You know what a logit is? Well, if you know what a logit is, then everything that we're going to do, you do on logits. And you switch out the distribution for the residuals from normal to conditional Bernoulli. But if you've never had logits before, which is the typical student that I teach, I can't teach you what a logit is at the same time I teach you what a random effect is. It's too much. So for that reason, those models I usually teach in an advanced course. If these are the types of outcomes that you need to be able to analyze, though, I can point you to materials and help you work through how these concepts will translate, because they do readily translate. So does that create an impediment for anyone? This idea that you should have plausibly normally distributed outcomes. Like, how do you measure improvement in physical activity or for physical capability?
Yeah, we could measure their behavior with an accelerometer, changing the activity itself, or you could measure physiological capacity, so we do a fitness test.
Okay, so like minutes of vigorous physical activity, that kind of stuff.
And then like that changes in memory or changes in the brain.
Okay, so
Put them all
brain,
together.
yeah, so stuff that's continuous.
Yes.
Right, yes, okay. How about you guys? What kind of outcomes change over time? Total score? That better be continuous, right? It's, or close enough? Close enough for government work, is the phase is? Yeah? Gentlemen? Ishmael, how about you?
Ours is personal assessment. I think sub-factor scores, item parcel scores are changing. Sometimes like 1 year later, if they think themselves, if they are self-motivated, let's say, I'm arbitrarily saying 5 out of 7 scale, it's gonna be in the mean 5.5. This person is feeling better this year.
So like
Change.
neuroticism or openness to
Yes,
experience, that kind of stuff.
openness.
Yep, so even though the items themselves are ordinal at best, you sum them up into something that resembles something that we can say interval-ish and call it good. Yes. All right, how about over here? Survey items summed into something or forming a latent variable?
They're summed into like a swarm.
So it's same deal as that in your work? Anything different or? No, you don't know? Okay, you can just nod then. You say, I'm good. All right, so point being, everything's gonna be normal to start with because that's easier. It's not, if you have non-normal outcomes though, we just switch up the model to form a different kind. More complicated than that is a measurement issue that is not a statistics one, and it's something that I can't help you fix in this class. The idea that the meaning of the construct is the same over time. So if I have a second grader and I want to measure math, I might ask them how to multiply 2 numbers together, maybe? That's hard for a second grader? Can I make this up? I'm not an educator. That sound about right?
Yeah, my son's in 2nd grade. He's
Okay.
hard with that.
Good, perfect, thank you.
Yeah.
My son is 3. He's learning what numbers are
Yeah.
at this point, so. But if I gave a multiplication of 2 digits to a high school student, that better not be measuring math anymore, right? That better be memory at this point. So the things that you're measuring, if the construct itself has to be measured differently as people change, then that's a different problem. These models don't make any sense if they're not applied to something that's meaningful. And so that's where the measurement work that this program is so well versed in comes into play. How do you design a study so that you can measure change and yet have continuity? And there are ways with linking designs. You know, you start out with a set of items that are easy, and then the next time you add a few harder ones and drop some of the easier ones, and the next time you add a few more. And with planned overlap, then you can have something that is a completely different test from the end to the beginning, but yet with overlap you can link it back together and have something meaningful. So I'm assuming that you've already done all of that. I think if it's a shorter term study, like something like minutes of vigorous activity, that means the same thing probably at baseline as it does at 3 months later, so you don't have to worry about that in this context. But over longer scales, it means something different. And I will point out that stats can't save you. If you do things like give a different test at pre-test than you give it post-test, game over. That's a confound of test and time that these models cannot solve. That's a design problem. So there's only so much that can be done with statistics. If the design itself doesn't lend itself to observing the phenomenon that you're interested in and of itself, game over. Another example that I'm familiar with from the aging literature, which is where I dabbled as a postdoc and as an early faculty member, is this controversy about retest effects when you measure older adults and to some extent younger adults, although it's less of a big deal. For a while, I'd say for several decades probably, a lot of the research on cognitive aging in particular was done through cross-sectional designs where you grab everybody from 20 to 80 and you measure them and you try to figure out how much of the differences in whatever cognitive outcome are due to age and how much is left over to be explained by other things. And then people started doing longitudinal studies and the findings didn't exactly map on. And so then the question was, well, if you have 2 different designs that give you 2 different answers, who's right? Well, you can't randomly assign age, right? That's never going to work. So people came up with criticisms from both ends. Well, cross-sectional studies are flawed because these are differences between people. We're not actually watching them age. Longitudinal studies are flawed because if you give someone the same test over and over again, they get better at it. So to whatever extent you would expect some sort of cognitive decline, it might be lessened because they're getting better at it at the same time they should be showing aging. And there were these models put forth without testing, actually, that we could solve it through statistics. They were called retest models. And I actually got a simulation study published in Psych and Aging looking at the properties of these models, and it turns out, no, you can't fix it. You can't, because it's confounded within a person. The next time you see them, they are both older, and it's the next time they've gotten the test. They're both practiced and older. That's a design problem. So the way to solve it would be to measure these phenomena over different timescales. So there's a study that you will see in several of my examples, several of the book chapters as well, that was started at Syracuse University with Marty Slowinski, and it uses what's known as a measurement burst design. In there, the purpose was to say, okay, just aside from aging, how susceptible are older adults to retest or practice effects? So they gave them response time speeded tests 6 times over a 2-week period. Now, maybe they had a bad couple of weeks, but they probably didn't age that much in a 2-week period. Whatever change that happened, we can be pretty sure is because you made them do this test 6 times and they get better at it. Some people call that practice, some people call that cognitive intervention. Right? Tomato, tomato. But what he did then is repeat that set of 6 assessments every 6 months. And so over a 6-month period of time, the extent to which people are not showing as much practice, or the extent to which their asymptotic performance, how good they get at the end, the extent to which that starts to decline, you can be reasonably well assured that that has more to do with aging than it does practice effects. But point being, there are no stats models, is that redundant? No statistics that can save design. So if you've confounded something by design, I can't help you. So multiple occasions in order to participate in these models. 2 is problematic, and I'm sure someone's told you this before, and you're just like, but the people don't want to be tested any more than that, and it's expensive and hard. Is that about right?
It's a combination.
Yeah, it's
More testing, more dropout, more costs.
yeah, it's when you measure real people, it's very hard, it turns out. Yeah, making up data is so much easier. But yeah, 2 occasions. If I have 1 point and 2 points, and I draw a line between them, how well does that line fit? Perfectly! So either you have measured each person's rate of change perfectly, or you have one common rate of change with some error around it. 6 of one, half dozen of the other. It's the same thing. The model cannot distinguish between those 2 alternatives. Once you get a 3rd point, now do my little thing, here's 3 points. Now if you draw a line, it can't fit perfectly. If it does, good for you, but it doesn't have to. There's room for both different lines for different people and error around the line. And so that's the point at which these models become useful, the point at which individual differences in just their starting point can be supplemented with individual differences in how they change over time. So that being said, repeated measures ANOVA, which is often taught as part of like an introductory sequence, is fine for 2 occasions. There's nothing wrong with it. There is an assumption that goes with these models known as sphericity, which is equal variance of pairwise differences that is satisfied by default with only 2 occasions because there's only 1 difference. So repeated measures ANOVA is fine for 2 occasions. It has the potential to be not fine once you get more than that. And so that's when these models really come into play.
Would you say if you have big missing data though, that the mixed effects, that repeated measures ANOVA is tough in terms of dealing with missing data pre or post?
Yes, because when people think repeated measures ANOVA, probably 99% of the time, What they're also thinking of is least squares estimation limit. It's the least squares that's the problem, not the ANOVA. The very first versions of longitudinal models or multi-level models we'll look at are ANOVAs, but they're done with maximum likelihood. And so yes, even if you had pre-post, if not everybody came back, right, which is what I'm guessing happens, you're still better off with something that uses likelihood estimation, even if functionally the model is just a repeated measures ANOVA model. Because then you're making use of all available data. You're not having to do list-wise deletion of anybody who's missing anything. Yeah, great point. So in terms of thinking about designing studies, different dimensions of sampling mean concerns about statistical power at different levels because you're powering the model to be able to do different things. So the more occasions you have, the better you can approximate different types of trajectories of change, be it linear or nonlinear, continuous, discontinuous, different sections of time, so semester effects, for instance. If you measure someone in the spring semester and you measure them on the last day of classes and then you measure them again at the beginning of the semester in August, do they pick up right where they left off? Or do they forget stuff? What do you think? Probably forget stuff, right? So that would be known as discontinuous change, where you need to be able to introduce some sort of break point so that you can actually see where how much the drop off is. Having more occasions allows you to do that better. More people or units of sampling then give you more power to address why is it that people change differently, to be able to test person level hypotheses. And in general, the same is true about any dimension of sampling. If you want to have good power to detect the effect of a predictor, you have to have a lot of units of sampling that pertain to that predictor. So for instance, in a repeated measure study where I have people who are looking at words, for instance, if I am manipulating different characteristics of words, I want a lot of words to be able to show the effect of that manipulation. The number of people is basically irrelevant. If I want to test whether subjects assigned to a control group do worse than subjects assigned to a treatment group, I need a lot of people. So these models don't get around the problem of needing lots of units for power. It's just that it's focused on different levels of analysis and different types of questions. So both are relevant. More occasions is better. There is an article that I think is really good still. It's an older piece, but there's a picture that I stole from it. This is John Willett. And he plotted out at different levels of effect size. So basically the y-axis here is power, and these are different lines for different ratios of how much of the variability in the data is because people change differently relative to just noise. And at every point here, 3 is much better than 2. It starts to asymptote out for good signals sooner, but more is always better. Even though it's hard, more is better. So vocabulary time. We doing okay so far? All right, where am I at? 119, good. I have a Fitbit because my husband wanted an Apple Watch, so I get his cast-offs for technology. And I was curious as to what my heart rate is while I'm teaching, if I'm actually burning fat or not. Not yet. It's intriguing to see what things it thinks are fat burning. Not lifting weights, by the way. It never gets above things, but like going up the stairs or carrying laundry, those things get me up there. But I digress. So vocabulary time. I said that different disciplines use different words and different notations, so we're going to keep drilling this and drilling this and drilling this until it's second nature. But in longitudinal data, so that's the type of sampling design we're focusing on here, we have 2 levels of analysis. Level 2 is person. So variation between people is known as between person variation, inter-individual differences, or time invariant. This, you can also think of this as cross-sectional. So every longitudinal study begins as a cross-sectional study. You have to measure everybody once before you can get them to try to come back. The extra part that longitudinal gives you is level 1. So this is somewhat counterintuitive, but it's within persons is the occasions. So this is intra-individual differences or time varying or longitudinal information. And this is the extra part. What makes these models tricky is that any variable that is measured over time usually has both kinds of variance in it. So if we take something like minutes of vigorous activity, when people walk in the door, do your participants differ in how much activity they get?
How much they have
Yeah.
day to day.
Yeah,
Yeah.
Certainly.
widely, yeah.
and you're hoping that no matter where they started, you're inching them up, right? So you're hoping to introduce both within-person change, but at the same time, you already have between-person variation. You take something else like self-perceived stress. If you measure somebody every day for a week, so those are known as daily diary studies or ecological momentary assessment designs, where they might beep you on your phone or your watch to put in some kind of rating. Some people are just more stressed than others. So if you averaged all of the ratings they gave you for a week, some people would have a higher average. To the extent that some people differ from each other, that's between. But within a person, if Monday is worse than Tuesday, that's within. And so you have both kinds of variation in the same variable. So when people think about variables measured at each level, if it's a person thing, it's only level 2. If it's something that's measured at each occasion, odds are good it's both. And so how do you take apart variables with different sources of variance and test hypotheses about them? So what is it that causes some people to have more stress than others? Well, systematic things, right? Poverty, family obligations, work obligations, it's chronic illnesses, right? Those are things that might differ, make people differ from each other. But none of those things can explain why Monday was worse than Tuesday. It has to be something that happened on Monday within persons, things that fluctuate over time, to explain what is it that made stress relatively higher than expected for this individual. And so that's a different question with a different answer. It's complementary information. You can also have interactions. So the idea that some people are more reactive to stress, there may be individual differences in that. Perhaps people who are higher in neuroticism are more fazed by day-to-day events that make them stressed out. That would be what's known as a cross-level interaction, where we have a between-person characteristic like neuroticism that is interacting with how stressed a person is at a given occasion. And I note here, as I said, people are level 2 in this case. But if you memorize the words between and within, it's the second part that changes based on the design, but between and within always hold. It's always between and within something. So it's going to be people here, but it could also be schools, animals, groups, countries, what have you. More vocabulary. These are words that I use to describe different types of sampling designs that lend themselves to different types of models. So there's a continuum in terms of how people think about sampling of time. The typical case, I would say, when people think of the word longitudinal, is on the left-hand side. What I would call within-person change, where the point of the study is to see how people change over time. So you have to pick occasions that are far enough apart to be able to observe that phenomenon. Models for this type of design are known as growth curve models in the literature. Now, even though you might be measuring decline, it's still a growth curve model. Even though your decline might be linear, it's still a growth curve model. It's never a decline slope model or something like that. It's always growth curve. That's just the terminology. But the key thing here is that time is on purpose. Time is in the context of whatever the phenomenon is, where it's long enough to see change happen for the reasons you think it should. The other extreme then is what I would call fluctuation. And this is where time is functionally irrelevant. You just get multiple measures per person so that you can see how relative relationships unfold. So I might pick every day for a week to ask somebody about their mood, their health, their stress, the amount of social support they received, things like that. Doesn't matter what week it is. I'm just capturing a snapshot of someone's lives. So time is irrelevant. If you're measuring things like social support here, some people might be higher than others on average, but it's not like social support is going to be higher on Friday than it was on Monday in some sort of linear fashion. You're not trying to fix them per se, you're just measuring them. So if time is irrelevant in terms of describing the data, you need different types of models than if time is on purpose. Some studies are somewhere in the middle. You might try to have within-person change, but find out you look more like this. And data that are supposed to be just about fluctuation may end up looking more like this. So we'll give you some stories about that later on in the semester. So before I jump into that, lots of words, questions. All right, then synonym time. So the models you're going to be learning, we are learning models that can do analyses for longitudinal data. That's the way that I would phrase it. The specific approach that I take in describing the models and their associated software fall under the heading multi-level model. That is my preferred term. But these same models go by lots of different names. So there's general linear mixed models or mixed effects. That's this. Random coefficients is another one that you might hear, random effects models. In education, these classes are almost always called hierarchical linear models. And that's because the person who sort of started off this trend of using these models in education, Radenbush, he wrote the book that was called HLM, and there's a software package called HLM. So it's sort of become ingrained in this. I will note that if you know the term hierarchical regression, that's not this. That's the idea of putting in some variables and then putting in another set of variables and then maybe taking some out. That's not this. That's a different thing, even though it's very similar in terms of the words. Special cases of these. So when you have models that fit certain types of designs or that contain certain features, they get called certain things. So you can think of this as like one of those build your own kind of places, like a smorgasbord, what's it called? Like Mongolian barbecue, like where you have a whole pile of ingredients, right? And you can throw everything you want in your bowl and go down the line. Like think of these models as the Mongolian barbecue. But if the whole array of ingredients is just sort of scares you and it's too much, usually those places have recipes printed on a chalkboard where it's like, okay, put some of this and put some of this, and then they give it a name, and then there's your bowl. So like, just think of these as specific recipes that can be derived from the Mongolian barbecue. I want to teach you about the barbecue though, because then you can make yourself whatever you want. So repeated measures ANOVA, that's one recipe that falls under this heading. It's when you only have one kind of random effect and it's an intercept. Growth curve models, or their friend latent growth curve models. The latent part means you use structural equation modeling software to do it instead of mixed modeling software, but it's the same damn thing. If you are in a job talk, you might want to throw in the latent. Makes it sound fancier. Within-person fluctuation, that's my term for daily Dyer, EMAs types of studies. Clustered models, so that term gets used for sampling designs in which people are nested within groups, where the groups are meaningful already, such as classrooms or schools. Cross-classified models is another one that's common in education. This falls under the heading of value-added models nowadays, where you want to be able to hold teachers accountable and differentiate unique effects of teachers on student performance. Cross-classified models allow you to do that. That's also the same framework where cross designs of persons and items are analyzed. And then also psychometric models. So I heard, let's see, we talked about CFA today and IRT, right? You've heard these things or taken the classes? At least this group, right? You've heard these things and taken the classes. Guess what? Every psychometric model is a multi-level model. A factor is a random effect. A random effect is a latent variable. They're all the same. The difference is in the terminology and the software that people use to describe them and what particular parameters you can throw in there, but it's all the same. So there's an expression, if you have a hammer, then everything's a nail. Everything is a nail. Once you have this hammer, you will see that you can just hammer everything. Everything is a multi-level model in some form or another. In this case, in the last case, it's items nested in people. Once you give each item their own parameters, like their own difficulty and discrimination, then items are nested in people, and you can think of them as within person. All right, more vocabulary then, in terms of how these models fit with the models that you already know. And for this class, I'm assuming that it's regression. And everybody did so good on my little quiz with the interaction term. Oh my goodness. Like, that has never happened. I was so hard. Normally, I have to spend a month on interaction terms in this course before I can get to the longitudinal part, but I get to shortcut that this time. So I'm very excited about that. But in terms of how these models relate to the models that you know, all models have two sides. The part that's the same as what you already know is what I call the model for the means. Synonyms for this include fixed effects, or the structural part of the model, and this is the part that you're used to thinking about in the context of answering questions or testing hypotheses. It's which predictors should I put in the model to predict this outcome? Do they need main effects, or do they need interactions with each other too? Is a linear effect for this slope sufficient, or do I need to have a quadratic term maybe for a nonlinear effect? Those kinds of decisions all go in the model for the means. And when it comes to testing hypotheses and longitudinal data, all of that works the same. So that's why it's so important to understand linear models, main effects, and interaction terms, because in longitudinal analyses, it gets very quickly that everything is an interaction term of some kind. So you have to know that from just regular regression in order to be able to survive. The new part, the part that you're probably not used to thinking about and we're told you had to make assumptions about instead, the model for the variance. Synonyms for this include the error part of the model, residuals, random effects, or if you want to sound fancy, the stochastic part of the model. That just means error. So this is the part that makes it different than what you know. So if you think back to your first regression course, y equals beta 0 plus beta 1 times x plus stuff. What's at the end? Here, I'll draw it this way. It's always drawn this way. What's at the end of the line? Error, an E or an R maybe? Who put that there? It just was, right? And you were told that those errors had to have three properties. Do you remember what they were?
Independent.
Yeah, there's one. Normal. Homoscedasticity, otherwise known as constant variance, right? And you had to check these things. And what happened if they were broken? Then what?
Transform.
Transform maybe, right? Well, you can sort of squish things to make it normal, right? But let's look at minutes of vigorous physical activity. I'm guessing in your data, if you were to make a histogram, there's a giant pile of people with zeros that just sat there all day,
Quite skewed.
right?
Yeah.
You can't take a giant pile of zeros and transform them into anything other than a pile, right? It doesn't work. You can take a log and sort of rein in a tail, so you might be able to fix normality, maybe. What about the other ones? What about independence? What if your occasions, you have multiple occasions from the same people or multiple kids from the same school? Can you transform away that problem? Nope. So you get a new model. That's what you do. There are different models that go with each of those broken assumptions. So if it's not normal, you pick what's known as a generalized version of the model, in which case it's not based on the normal distribution, it's based on some other kind of distribution. The model has transformations built into it that are designed to keep the predicted outcomes within the range they're supposed to be. Constant variance and independence are the two that this class is going to fix. And the way that we fix it is by adding more error terms. The problem with only having one E is that that one E pertains to the dimension of sampling for Y. You have differences between people in a cross-sectional model, and so you have E's that represent remaining differences between people that you didn't explain in your model. We need another kind of E to get at remaining differences between occasions that you didn't explain by your model. And if your people are nested in schools, We need yet another kind of E to get at remaining differences between schools that you didn't explain by your model. Think of it as like a regression lasagna, where you have these layers, and each layer of sampling has something to predict differences for it, as well as something to capture differences left over. Additional kinds of E's. Those are known as random effects. That's what's going to happen. 10 minutes. So, yeah. So to help you search for other material related to these things, I want to give you the appropriate Google terms and break this down, because this is something that I found confusing in terms of lists of synonyms and things. So the term general, when you see that term, that means residual is supposed to be normal. That's what it means. Linear, that means additive effects in a form of slope times predictor plus slope times predictor plus slope times predictor. Even if the predictor is a squared term, it enters linearly in the model as slope times predictor. That's what linear means. So that shares across these. When you add the ised to the general, some kind of not normal. So logistic regression, for instance, to predict binary outcomes, that's a generalized model. Zero inflated models, right? For a pile of zeros and then some sort of distribution after that, that is a generalized model. And so we have two sets of words here, one for cross-sectional data, where you have one dimension of sampling. That's either general linear or generalized linear, where you only have fixed effects, meaning you only have one type of predictor in the model and everybody shares the slope for that predictor. The difference is what kind of error distribution you have, whether it's normal or some kind of not. Where we're going to be here is highlighted in the blue rectangle when you have more than one kind of sampling, such as different people, different occasions. Then we add this term mixed. So you'll see this as either mixed or mixed effect, same thing. The term mixed means fixed and random effects both at the same time. Random effects are extra error terms that track differences in extra dimensions of sampling besides the one you started with. So this semester we are going to learn general linear mixed models. And if I get the chance to teach an advanced class like I normally do, then we will head into generalized linear mixed models, in which you get to learn all of this vocabulary and do it on logits, or probits, or tobits, or I think that's all the obits that I know of, but you get the idea. One side note here, only this first box here, this general linear model box, is able to be analyzed using least squares. When I say least squares, I mean the stuff that you can do by hand and probably had to at some point. If you've ever calculated sums of squares, expected mean squares, f-test, blah, 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 that only goes with this. Once you leave this section, you can't do it with least squares anymore. You have to do it with something else, and that something else is what we'll talk about. We're using likelihood estimation in this course. Bayesian methods is also something that I won't get a chance to talk about, but that's another way to solve the problem. So things that you can calculate by hand stop being useful very quickly. And they have their own other problems, such as how they handle missing data, which we'll talk a lot about as well. All right, we're starting to close in on the end of class here, just a few minutes. Any questions before we see where we are here? Okay, one more slide and then we'll go. How's that sound? I figure we already trudged out here in the snow, right? If I let you down, if I let you go early, I'd be letting you down, right? That's the way I feel. But last case here, longitudinal models can be estimated with all different kinds of software. So if you've taken an SEM course, anybody? Or sat in them? Structural equation models? Yes? Did you have any longitudinal? Did you have a week on that, probably?
Yes, last part, we went together.
Okay, so I apparently that stuck really well, right? Yeah. So these models can be estimated lots of ways. Models and software are logically distinct. It's kind of like, I want to buy this. What store sells it? Right? If I want to buy Cheerios, I can get that at Target, I can get that at Walmart, I can get that at Hy-Vee. right? If I want to buy motor oil, I can't get that at Hy-Vee probably, although maybe the one in North Liberty. It's so fancy. There's like a Sephora in there. Apparently you've been waiting for it since 2009, I hear. It's a thing. There's t-shirts that yeah, it's a thing. No, there's this huge section of beauty in there. It looks like a Sephora in the middle of the Hy-Vee. It's crazy. You have to check it out.
We don't have one on the east side.
Yeah, I was just really surprised. Point being, longitudinal models you can buy at these different places. You can buy them at the multi-level modeling store or at the SEM store, because latent variables and random effects are the same thing. Now that being said, why do I do it from the mixed effects multi-level way as opposed to SEM? Because I think it's easier. It starts from regression, you add more stuff to your regression model, and so I find that to be an easier place to start from. It also generalizes easier to additional types of sampling. So it's pretty rare that it's only people and time, because people show up in units. So you might have married couples, you might have students in classrooms and schools. There's all kinds of ways that people are naturally grouped, even if you didn't intend it to. Maybe if you have some research assistants that are better than others. If certain subjects were measured by certain people and people differ in their fidelity, you've got something that's grouping there that you have to address. So those sorts of problems are more easily handled, I think, from the multi-level perspective. And I mean that in terms of how painful is it to ask the software to do what you want to do. SEM, though, is another way to do these exact same models. It requires a different set of notation, a different data structure, and a different way of thinking about it. But there is a lot of commonality here. Unfortunately, there are only certain kinds of questions that are answerable via multi-level mixed effects software that's univariate. So the models that it can't do, SEM software can do. And so that I'll try to make these distinctions as I go. But know that for like 80% of what we're going to talk about, it's either one is fine. I just think it's easier to start here. Multi-level SEM is the intersection of the two. That really just refers to software. It's the idea that you can fit structural equation models for between-person things and structural equation models for within-person things, as well as path models. So if you have questions about mediation, for instance, then the software that does this is what you need. So this stuff can be confusing in terms of how it relates to each other, and that's something that I'll try to help us sort out. So what we'll do next time is my sales pitch. Why should you come back? We will do that as well as SAS. So after getting the survey back, I decided to stick with what I had typically done, which is feature SAS most prominently. That being said, you can use any other software package you want for your homework and probably get the same answers. I'm almost 100% certain that everything will turn out the same. But because I had to stick with something, and several of you have had some SAS experience, sometimes a little long ago, but I'm going to spend the next couple classes just reviewing basic stuff like how do you get a data set in SAS? How do you make a variable? How do you sort it? How do you merge? Just basic stuff like that, so that when we get to the models, that stuff isn't the stuff tripping you up. If that type of content, if you look at the stuff that's posted for Thursday, I'll send you an email when it's ready, but if you look at that stuff and you think, I know how to do this, you don't have to come. That's fine. I just want to make sure that it's not data stupid stuff that's getting in the way of learning the models. I've made that mistake before. So we'll finish this, this lecture, do the SAS stuff, and then we'll do some reviewing of general linear models next week. So, sound good? All right, anything else before we adjourn? All right, well, thank you for being here. I hope to see you on Thursday.